The savanna is known for its predators: lions hunting in tall grass, hyenas circling herds, elephants moving across the plains. But what if the most ruthless battle here has nothing to do with animals? What if the real war is happening underground, between the grasses themselves? A war fought not with claws or teeth, but with toxic chemicals. A war that decides which plants live, which die, and what the entire savanna becomes. This is the secret conflict shaping one of Earth's most famous ecosystems. And almost nobody knows it's happening. The African savanna is one of the most iconic landscapes on Earth. Home to elephants, lions, zebras, antelope, and hundreds of other species, it's easy to look at this environment and imagine balance, harmony, and natural coexistence. But what most people never see is the war happening beneath the animals' feet. This war isn't fought by predators. It's not a battle between lions and hyenas, or between elephants and drought. The fiercest competition in the savanna is actually happening at ground level. It's a silent chemical war between the grasses themselves. Savanna grass species fight for space, water, sunlight, and nutrients in ways that are far more strategic, aggressive, and complex than most people realize. They use a biological weapon called allelopathy, a process where plants release chemical compounds into the soil to weaken, suppress, or kill neighboring species. What looks like an ordinary field of grass is actually a chemical battlefield. At first glance, grasses appear passive and harmless. But every savanna grass species is competing for survival. Some grasses grow tall to steal light. Others develop deeper roots to reach water faster. But the grasses that truly dominate these ecosystems aren't just physically competitive, they're chemically competitive. Allelopathy allows a grass species to create a chemical zone of control. When the plant grows, it releases compounds through its roots, leaves, or decaying litter. These chemicals seep into the soil and alter the environment around them. They can prevent other seeds from germinating. They can slow the growth of rival roots. Some compounds even change the soil's microbial community, giving one species a hidden advantage in the long term. In the African savanna, several grasses are known for their strong allelopathic behavior. Species like Imperata cylindrica and Bothriocloa pertusa can release chemicals that stop other plants from establishing themselves. These grasses don't just compete, they conquer. Imagine a patch of savanna where only one type of grass grows in a perfect circle. To most people, it looks natural. But ecologists know that these uniform patches are often signs of chemical warfare. It means one species has successfully altered the soil chemistry to push others out. Nothing else can grow there, not because conditions are poor, but because the soil has been weaponized. And this battle doesn't just affect the plants. It shapes the entire savanna ecosystem. When a single grass species dominates an area, plant diversity decreases. And when plant diversity decreases, everything above it is affected. Herbivores lose access to certain types of food. Pollinators lose specific flowering plants. Birds lose nesting materials. Even predators feel the ripple effect as animal movement patterns shift in response to changing vegetation. Invasive grasses with powerful allelopathic traits take this competition even further. When a non-native grass species enters the savanna, it can completely reshape the ecosystem. These grasses often grow fast, resist grazing, and deploy allelopathic chemicals that native plants have no defense against. Entire regions can be overtaken in just a few seasons. Some invasive grasses even alter fire patterns. They grow denser and taller, increasing the fuel load. Fires burn hotter, faster, and more frequently. Native grasses that evolved to survive periodic fires suddenly can't keep up. But the invasive grasses recover quickly, allowing them to spread even more. In this way, chemical warfare at the plant level can change the entire fire cycle of a savanna ecosystem. What started as a microscopic chemical interaction becomes a landscape-scale transformation. This invisible struggle becomes even more complex when we look at how different grass species interact with soil microbes. Some grasses use allelopathy to kill off beneficial fungi relied on by competitors. Others develop partnerships with bacteria that help them break down nutrients faster. The soil becomes a living chessboard of biological alliances and chemical attacks. Every patch of savanna you see, Every open plain, every evenly spaced grassland has been shaped by these hidden battles. The structure of ecosystems is not just the result of rainfall, grazing, or climate. It's also the result of plants strategically eliminating each other through chemistry. This chemical warfare isn't unique to the African savanna. It happens in prairies, meadows, and forests all over the world. But the savanna is where the scale of the conflict is most visible. The grasses here form vast territories. They grow fast, recover quickly from disturbance, and live in tight competition with grazing animals. That competition pushes them to evolve stronger and more efficient chemical weapons. Allelopathy also explains why certain areas remain barren long after plants have died. The chemical residue left behind can persist in the soil for months or years, preventing new species from growing. These dead zones are often misunderstood as signs of drought or poor soil, but they're actually scars left behind by chemical battles between plants. Ecologists studying allelopathy in grasslands use soil sampling, chemical analysis, and controlled experiments to test how different grasses interact. When they grow certain species together, root growth slows, germination rates drop, microbial communities shift dramatically. The chemistry of competition becomes impossible to ignore. These discoveries are reshaping how scientists understand savanna ecosystems. The traditional view focused mostly on animals, how grazing patterns influence grass structure, how predators shape herbivore behavior, and how climate determines plant growth. But now, ecologists recognize that the plants themselves are active participants in shaping the ecosystem. They're not passive victims of grazing and rainfall. They're strategic organisms fighting constant, invisible battles. The savanna is not a peaceful landscape. It is a living battleground of chemical weapons, shifting alliances, and microscopic warfare that determines the fate of everything above it. The elephants, zebras, lions, and antelope are simply the most visible layers of a deeper conflict. Next time you look at a grassy plain, understand that every blade is part of a silent struggle. Every patch of land is claimed, defended, or conquered. The savanna's beauty hides a constant war of survival, one where grasses fight not with teeth or claws, but with chemistry. A war that shapes the land, the animals, and the future of the ecosystem. And as climate change, invasive species, and shifting weather patterns alter the savanna, this chemical warfare will only intensify. Some grasses will disappear, others will rise, but the battle will continue, molecule by molecule, root by root. The story of the savanna is not just a story of wildlife, it is a story of plants waging one of the most sophisticated forms of biological warfare on Earth. A war we rarely see, but one that defines the landscape we admire.